Thanks for joining us for the morning panel. This panel is going to discuss autonomous vehicle opportunities in Michigan. We're going to begin with Eric Dennis, who is Transportation System Analyst for the Center of Automotive Research here in Ann Arbor, Michigan. Please welcome Eric Dennis.
Hi guys. Hey. I am Eric Paul Dennis. My job title, can I get the slides back up? Yeah, my job title is Transportation Systems Analyst, but if you're roboticist, that might mean something specific to you, and it actually doesn't mean that. In this context, I'm actually a Transportation Policy Analyst. So what my job is really is to understand what's important about this technology and how it can affect the world so that I can communicate that to other people. And the scope of my job really is beyond self-driving cars, the kind of thing we're here to talk about today, beyond robotics, really beyond technology. But it seems that recently, self-driving cars is kind of all anyone wants to talk about. You guys might be familiar with Google Trends. It's this tool that lets you visualize internet search data to kind of give you an idea of how popular certain search terms are relatively. So I did that here with a couple of terms, driverless and self-driving, related to this driverless car phenomenon. This technology has been in development for decades, literally decades, but it's actually only been within the last 2 or 3 years that everyone's really started to pay attention to it. I think the ramp up really started in 2012. A couple of important things happened. One of the things, Google put out that video that you guys may have seen where a self-driving car drove a blind man to Taco Bell. Have you guys seen that? It was pretty cool. It was a little bit staged, but it was still a big step, and that really caught the attention of a lot of people in industry. Another thing that happened around that same time is that the state of Nevada actually passed a law that specifically allowed automated vehicles, self-driving cars, to test on the public roads in the state of Nevada. And so that got a lot of people in the policy and government world, people like me, paying attention where we may have not been before. So when I started this job, no one ever wanted to talk about automated vehicles. I was much more likely to talk about connected cars or general transportation infrastructure. But in just the past few years, it seems like now people only want to talk about automated vehicles. And I'm sometimes even saying, maybe calm down. This is, there's a company called Gartner Incorporated that has this thing they call the hype cycle of emerging technology. And so every year they put out this report where they talk about how hyped certain technologies might be. They do this with, they've done 3D printing and augmented reality, the Internet of Things, whatever that is. And since 2012, what they call autonomous vehicles has been on this hype cycle report. And it has very quickly catapulted its way to the top of what they call the peak of inflated expectations. And that's pretty much where we are now. How many of you guys have heard somebody say, or maybe read, that driverless cars are coming and it's just a matter of when, but not if? You heard that? Yeah, if you read popular press, a newspaper, a magazine, that's a very common trope. It's not true. It's a possibility, it's a probability probably, but that technology just isn't here yet. Driverless cars are coming and it's just a matter of time. That's that view from here on Hype Mountain. But technology isn't this thing that just proceeds under its own power. Technology is people. It's 100,000 people across the world doing their individual parts to make this happen. And so actually that's why events like this are so important. This future isn't determined yet. We're not here to learn about some future that we're just waiting around to happen. we're here to talk about the future that we want to make. And so thank you all so much for coming today. I'm really pleased to be a part of this, and I'm looking forward to a good discussion. Thank you so much.
At the very first Robotics Day at NCMS, we actually demoed an autonomous vehicle in our parking lot. And it was amazing because nobody had ever seen one before other than on video. And now, at this Robotics Day, we're going to have a tour this afternoon of a test facility dedicated to autonomous vehicles. Our next speaker is John Maddox, who is the president and CEO of the American Center for Mobility, and I'm sure he's going to have a lot to tell us about the subject. Thanks, John.
Thank you, Phil. Good morning, everybody. It's great to see so many young people here at this event involved in robotics, because I will tell you that robotics, and in this case, we'll talk about self-driving vehicles, really is a huge opportunity for future, to really enable a career, but also to do good things for society. So I definitely glad to see so many young, interested folks here. As Phil mentioned, later on today, you're going to go over to M-City and have a tour of M-City. So I won't dwell on this too much, because I know my colleagues are also going to talk about it in the afternoon. But I want to say that M-City, which is just across the street, has been a huge success for us at the University of Michigan, as well as our industrial partners that use it. And I want to say that M-City was really conceived as kind of a training ground or a research ground for automated vehicles. I call it kind of a realistic, evil playground. It's a place where it looks like the real world, so the vehicle thinks it's in the real world, but as the Ford speaker mentioned earlier, it's a safe place to test and a safe place to kind of get your feet wet. It's evil in that it tries to incorporate as many different difficult scenarios as possible and bundle them all into one small area. And of course, it's a playground because it's about research. It's about taking a concept and putting it into a first physical reality in a way that's safe and progressive. And like I said, you'll see that. But there's, as Eric mentioned, there's still a lot of work to be done on automated vehicles. And I'm not going to talk about this entire list of things, but just rest assured that as you all are graduating high school and college and then graduate school, there will be lots and lots of jobs and lots of work to do on automated vehicles for the next 20 to 30 years. Now, having said that, I do believe that we will see these on the streets in somewhat mass production in a much shorter time frame than that, but they won't be perfect and they won't do everything. So there's a bright future, if you will, in connected and automated vehicles. So we've built M-City. It's been quite a success. It's highly utilized. Now we are transitioning to that next phase. As the products are coming out of the research phase and into the product development phase, we need a new facility, another facility, and we're going to build that out at Willow Run, which is an airport and an old facility about 10 miles east of here. And right now, this is a picture of what it looked like about a year ago while the building was being torn down. It's an old GM and Ford manufacturing site. Now it's a big, flat, blank slate. We can do with it what we want. So it's a huge opportunity to take the concept of M-City out of the research world and into a production world. Here's a kind of a diagram of the different types of surfaces that we will have there, and I won't go into detail here, but it will be, in short, much more comprehensive and complete than M-City is right now. Here are some schematics or some artist renderings of what it might look like. And mostly it looks like the real world. That's the goal. It looks like real roads, real buildings, at least to a vehicle, intersections, traffic lights, trees, water features, hills, et cetera, et cetera. And we are fully taking advantage. The site has a huge history of innovation. Back in the 1940s, before any of us were probably born, the government asked Henry Ford to build a facility that could build one plane a month. And Henry Ford said, well, I think we can do a little bit better than that. And through a lot of innovation, he created the first assembly line for aircraft at this site, as well as many other innovations in manufacturing. And in the end, he built one plane an hour. not one plane a month. So I think there is an incredible history of innovation and technology and huge gains in productivity for society at Willow Run, and we're going to take full advantage of that and to keep that spirit alive. So with that, I'll turn it over to the next speaker.
Our next speaker comes from an organization that has a lot of experience of working with robotics. I'd like to introduce Rob Karlsen, Research Lead, Ground Vehicle Robotics, U.S. Army from TARDEC.
Yes, I'm from TARDEC, the Army. We're in Warren, Michigan at the Detroit Arsenal. TARDEC stands for Tank Automotive Research Development and Engineering Center. And we are co-located there with the PMs for the Army, which buy all the vehicles for the Army, maintain them, and dispose of them at the end. And so we have a close working relationship with them, and they are getting interested in autonomous vehicles as well. As you know, we've been working on it for a number of years, and now it's becoming realizable and affordable enough that they are actually considering putting some robotic technology into the military ground vehicles in short order. One problem with the Army has is that we have a small base of vehicles compared to the commercial auto industry. We deal in tens of thousands of vehicles instead of millions, and so we can't really afford to do all this development ourselves, and so we do rely on commercial auto industry to bring down the price of all the sensors that we need to enable this type of technology. We're interested in multiple types of vehicles, mainly the bigger vehicles, the trucks and so forth. And so one of our biggest programs is trying to develop a convoy system that we can take people out of some of the vehicles and have them drive by themselves by following the vehicle ahead of them. But for the near term, there will be people in all the vehicles, and we're installing things like active safety and driver assist technology to aid the drivers to be able to either drive better or to be able to do other things besides drive, so that the vehicle maybe can drive by itself for a while. They can look for IEDs or the bad guys. We are also interested in logistics is big for the Army. They usually say for every soldier there's at least 10 other people behind them supporting them, and so we need to move lots of supplies and with the trucks and with planes and with people too. And so we're actually looking at something called automated ground resupply, which is going at the whole logistics chain, not only the trucks, but also things like forklifts and so forth, automating that so we can actually have a wholly automated system where we can move material from bases, load them up into planes, deliver them in theater, then put them on smaller vehicles and give them out to the soldiers out in the field. And so that's one of our larger programs. We're also interested in sort of mid-sized vehicles where maybe from 500 to 2,000 pounds, where they would be a tool for the dismounted soldier, that they could be like a mule, that they could carry the soldiers, some of the soldiers' gear, their food, their water, their bullets, and so forth. And so in that area, we're looking at things like advanced human-robot interaction, like having the robot be able to recognize gestures, for example, to go over here or to stop. Maybe use some speech control type of things. We also want the robot to have some understanding of the situation. So if the robot sees the soldiers running for cover, that it will act accordingly, maybe also look for cover. We don't work as much in the small vehicles right now, but we have in the past, things like the PackBot and Talons, things like the robots over here that maybe are used for IED. We have some efforts in there, but what we're doing now is kind of assisting the PM, because they're also trying to field some smaller robots, about the 20-pound variety that the soldier can carry in their knapsacks. In terms of the basic research, that's usually handled by the Army Research Laboratory out in the DC area, and they are looking at things like what we call micro-autonomous vehicles. So these are the little flyers, the little drones, the little crawling vehicles that they're less than a half a pound and they can fit in your hand. And so the Army Research Lab is doing a lot of work in that area, and then they would like to transition that to us in later years. But that might be 10, 15 years in the future, because that's a really difficult problem especially for ground vehicles. There's so many obstacles on the ground that it's hard for little things to move around, like insects can, or like cats or squirrels and so forth. So in all, the Army is really interested in a lot of this, all these different scales of robotics. We're the ground vehicles, but there's other organizations in the Army that are interested in the flying vehicles and so forth. And the Navy, of course, is interested in the underwater vehicles as well as the surface vehicles. So the military is interested in all these different types of technologies that robotics can play a role in, and you all can, it's a possible place of employment. We don't do all the work. We contract out most of it to the universities, to industry, to the big defense contractors, and also some of the small businesses. So all that technology then kind of flows to us and to other parts of the government. Thank you.
Our next speaker is Tom Waligora, Chief Robotics Engineer from Pratt & Miller Engineering.
Hey everybody, thanks for being here, or coming here. I just wanted to take a minute to introduce everybody to Pratt & Miller. See if I can figure out how to make this go forward. There we are. We're a small company, engineering company out of New Hudson, Michigan. Our history is in motorsports, but we're taking the techniques in the process that we've learned and grown and evolved in motorsports and applying them toward advanced robotics, advanced OEM, advanced automotive, as well as robotics. So I think what I take from this is it's a merger of different capabilities and techniques to rapidly develop products. So in this, you see a lot of different skill sets. Oh, so there's my cue down there. To go from the design aspects to the development, to the build and the integration of those concepts into a solution, and then moving those solutions forward in the industry. So, our history has been through the race industry, but we're applying those forward in all those other aspects, which is where you get a race and win. So developing those, in what I like about the automotive or the industrial robotics and autonomous vehicles is you create these building blocks across different technologies, and you're able to, once you kind of own and understand those building blocks, you can apply them to almost any robotic platform, be it a ground vehicle or an aerial vehicle, understanding the kinematics that go behind it, the calculations, the control software, and then applying that in different ways. So you can see some of the images that are listed above have collision avoidance systems, the Robonaut 2 humanoid robotics. Once you understand the math and the science that goes behind that, and then you develop the technology, you can apply it to a lot of different industries. So us at Pratt & Miller, we kind of try to focus on enabling the autonomy layer, where we take in the perception system and the perception data from a strategic partner, and we apply that to the mobility engine that we've created to maintain a stable vehicle or a stable platform. So if you imagine you have the sensors that are the eyes of the system, we would get that data and we would compute it and make sure that the vehicle is able to move forward and remain stable in that process. And in that, I think just to go back to what I mentioned a minute ago, was harnessing those different technologies, which is the part of the slide that says actuator systems, and the bimodal part is you create those building blocks, those by-wire systems, and you can apply those to a ground system, or you can apply those to a vehicle that's driven sometimes by person and sometimes by an autonomy or a teleoperated vehicle. So really merging all of the different worlds. And then creating a product in the end that's actually able to do something, which on this was the demonstrated vehicle that we've done. I guess this is trying to bring home that same idea where all of robotics is created by a lot of pieces and building blocks that are developed over time, and being able to apply those for specific applications. And in this topic, we'll discuss some of the autonomous vehicles. I'm going to go through because we're trying to be faster. I'm going to skip that slide. So on here we created this autonomous vehicle target system. I really just want to present that as an example of how to apply these pieces. So on this system, we developed it's a by-wire, waypoint following autonomous platform that takes in a group of decision points that you would provide it. So turn left, turn right, stop, go faster, things like that. So you give it, you teach it these behaviors, and then based on the situation that it's in, it decides which of those behaviors to present to the world, right? So, and on this, the way that those behaviors are modified is it's training people to marksmanship. So when the vehicle recognizes that it's been hit in a defined zone, it will look into its database of behaviors and choose one that's applicable for that scenario. So I just had a quick video that shows that vehicle in operation. So in this, we were trying to create kind of a relatively universal platform, so you can put a lot of different payloads on it. On this, it has a silhouette of a truck, and we defined the different zones on that truck as a hit zone, a mobility zone, and then the vehicle reacts based on where it was hit and what the hit state of the vehicle was. And on this exercise, every application is a little bit different. So on this one, we were really trying to keep costs at a minimum. You can imagine if you're putting this vehicle out on an infantry range, it's going to get hit. So you want it to be inexpensive. So we integrated a lot of different off-the-shelf parts, and then we practiced some of our innovative process and novel architectures to create something that is a lot more capable than what's out there, that isn't at a price point that's not achievable. So here it just shows some of the decision making, route planning, and how to create those training scenarios. There's a lot of back and forth between the use case, or the user base, and the engineers to develop a platform and a tool that works for the application and gives them the advantages that they want to have. Take your time. All right, so I'm going to wrap it up just so that we can get the panel moving and we can get some discussions going. Thanks, Phil.
So as students and educators in the audience, we want you to know that these are all activities that are happening here in Michigan. These are all places you can work. These are real people. This isn't happening in California. It's not happening in Massachusetts. The commercialization of this technology is right here. And that's important for you to know as you're planning for your careers moving forward. On the panel, tell us your origin story. How did you get to where you are right now? And do you have any suggestions or guidance for students who would like to end up doing similar things to what you're doing right now? Eric, could you start?
Well, the first thing I would say is be open to opportunities. I never planned on working in the auto industry. I'm actually a civil and environmental engineer by original education, and then I also got a master's degree in urban and regional planning, where I was especially concentrating on economic and community development. And so you would think that none of that has anything to do with what my expertise has recently become, which is transportation systems, automated vehicle policy, things of that nature. But I developed a habit of learning to learn, just being open to things that were interesting. And one thing, well, since you kind of brought this up, one thing that I can say how I got where I am, I really wanted to stay in Michigan. So when I graduated with my master's degree from the University of Michigan in Ann Arbor, I basically concentrated my job search on Ann Arbor, and I would have gone anywhere in Michigan, but I really didn't want to leave. And so I found myself here, but I'm very happy with it. It's not what I thought I would be doing. I actually thought I would be studying vernal pools, temporary pools caused by rainwater and floodwater in the spring as an environmental engineer. But what I'm doing now is very interesting. I'm very happy with it.
Rob?
I always liked math, science, puzzles, things like that, and so I got a degree in physics. And after school, I just happened to throw in an application to TARDEC, and they called me out. I actually grew up in Washington State, and they flew me out and offered me a job, and I started off in the Army's survivability division there, and looking at modeling human vision systems through computer analysis and analyzing camouflage patterns. And then when my boss moved over to robotics, I followed him, and I've been in robotics for the last 10 or so years. And so sometimes you just don't know where you're going to end up, but if you get a good background in science and math, then you can go pretty much anywhere you want.
Thanks. Tom?
We good? There we are. I selected my engineering background based on watching movies, so Short Circuit and Terminator. I thought that's what I want to be. That's what I want to make. So I got involved in robotics competitions. I think that's a really good seedling for applying education. So I did it in college, but getting involved in high school is, obviously that much sooner and that much faster in the learning curve. I did underwater robots. I think just to repeat, being open to opportunities. So when I graduated college, I thought I want to do underwater robots. I went to a company that primarily focused on that, but had a small aerospace division in which I transitioned into doing satellite deployment systems and ground rovers for the Johnson Space Center. And like you just continually evolve these. It's one primary skill set with it, which is the STEM, science and engineering and math, and just being able to apply those and continually accepting those opportunities as they arrive, just brings on other opportunities. So I transitioned from that into mobility platforms back here in Michigan again.
John?
Yeah, I think I would echo some of that advice of find your passion, but be flexible. So my history is I grew up near Baltimore, Maryland, right outside of Aberdeen Proving Ground, as a matter of fact. When I was 13 years old, I decided I wanted to work for Ford Motor Company doing engine design. That was my passion. I rebuilt my first engine when I think I was 13 or 14 years old. Well, there was one problem, and that was moving to Michigan. And so, I moved from Baltimore to Washington, D.C. I still love the East Coast, but moving to Michigan was kind of a daunting thing, but I took the plunge. Ford made me a great offer, gave me a chance to follow my dream to work in engine design. But at that point, I had kind of already said, well, this safety thing is kind of interesting also. So I started working in the Ford safety arena and found out that was really more interesting to me than my original thought on engines. But bottom line is, and by the way, for the record, I still live here in Ann Arbor. I've moved away and back 4 times since I moved here originally. So I think Michigan is a great place to live, and certainly we enjoy it here. And it's going to have a great amount of activity in automated and connected vehicles for a long future, as I had said earlier. So my advice, find your passion, but be flexible.
John, just to follow up on that, what's so unique about the environment here in Michigan that lends itself to the commercialization and innovation of new automotive and mobility technology?
Well, there's a lot of, I guess to sum it up, what's unique about Michigan is this incredible confluence of expertise and activity. I mean, I didn't show a map that I normally do show, which shows the amount of activity going on connected and automated vehicles here in Michigan is really the only place like it in the world. And believe me, I've been to every major automotive community and country in the world. And I'll tell you that Michigan has this expertise that runs very, very deep, from research all the way through design and into production and verification. Those all sound kind of boring, perhaps, but in reality, that's what it takes to develop and market a product, including an intelligent product. And so now what we're seeing here in Michigan is this incredible confluence of activity is really accelerating dramatically and focusing on this connected and automated vehicle space. So there's no other place like it in the world. Certainly, there's great things going on in other places, but no other place has the concentration of this activity and expertise that Michigan does.
Tom, when Pratt & Miller goes to hire new employees or new engineers, what kind of qualities are you looking for right now?
So I think general aptitude, which is a given, but I think just a desire to learn and to move forward and to try new innovative things. Maybe self-motivation, being able to take on a challenge, accept the challenge, and then own it yourself and move forward and see the holes in that task, and maybe being flexible as you're going through that evolving design or test or validation process, whatever the case is, and moving with that and understanding the changes that are needed to meet that end goal.
Thanks. Rob, you mentioned that TARDEC uses a lot of local companies and a lot of companies to outsource some of the work. What kind of companies do you guys work with?
Well, some robotics companies. You have one here, Quantum Signal. We've done a number of SBIR contracts with them. That's usually how we get companies through the SBIR process. I think Pratt & Miller, we've done some contracts with them as well. It's usually always competitive. It's a lot of people interested in robotics, and I know we've had some SBIR projects on, especially computer vision, where you get 30, 40 proposals in, and half of them are junk, but the other half are pretty good, and it's hard to make a decision. So there's lots of talent out there, and it's very competitive.
Eric, you talked about the trough of disappointment. What do you think is the biggest barrier to get through that to actual common commercialization for autonomous vehicles?
I don't think there's one biggest barrier. There's several tiny barriers built on top of themselves. We're not there. We're not quite there with the technology yet. Nobody's ready to sell any vehicle that they're willing to let average consumer get in and have it take them down the street. So there's still a lot of work to be done on the technology side, and there's just as much work to be done on the policy and legal side to however these machines develop, however this technology develops, there's going to have to be a regulatory infrastructure to let them operate in the world and let them operate in a way that is for the greater good of society. And there's a lot of challenges on both sides.
So the students here, I'd like you to appreciate that we have representatives from all different kinds of organizations. Ford is a really big company. Pratt & Miller is a smaller, nimble company. Quantum Signal in the back is a smaller, nimble company. We have representative from an organization that's going to be doing groundbreaking research and validation of autonomous vehicles. We have people from the U.S. Army. So there are lots of different ways forward. So a question to the panel, and I will give it to whoever wants to take it. As the students move forward, as you walk around and see the different competitions with RoboFest and FIRST, what kind of skills do you see that these students can focus on that will benefit them later? Eric?
I don't mind taking it if you...
That would be great.
All right. So I think I mentioned a couple times, but I would say all of them. Like understanding, so if you take the FIRST robotics competition, there's a lot of teams here, there's a huge swath of skill sets that are involved in that competition. It's not just being able to machine parts. It's not just being able to understand the game. It's business, it's marketing, it's documentation, it's team leadership. It's a huge assortment, and you can look at these competitions and pick out that piece that fits your goals and where you see yourself into this. And as you're doing that, you keep track of the other ones that are going on in the background. Maybe you don't want to focus on them now, but understanding how they impact the total system, it'll make you a better team player. So you'll be able to get on these innovative groups and change the world or change the things.
Yep, I would add to that also that clearly the basics of science and math form the foundation for the skill set needed for any kind of technology development, and those are really critical. However, it goes far beyond that. Certainly into the college years, the basics of physics and chemistry and mechanics and materials also quite important. But I would say maybe more important than any of that traditional academic skill set is a skill set of creativity and open-mindedness and kind of an idea of sticking to it. Once you start a project, I think somebody said, kind of own it. Take that project, take that problem, figure out a solution, and own finding a way through that solution. Those are critical skill sets.
All right. Can we have a round of applause for our panel?